We are asked to prove that the limit of the rational expression 3n plus 1 all over 7n minus 4 as n approaches infinity is equal to 3/7. We are to use here the definition for the limit of the sequence, which tells us that for every epsilon greater than 0, there exists a natural number such that for n greater than that natural number, which tells us that a certain expression or sequence is said to converge to its limit if for every epsilon greater than 0, there exists a natural number k such that for all n greater than that natural number k, the terms of the sequence x sub n satisfy, okay, this is per definition, the absolute value of your sequence minus your limit x is less than epsilon, however small that epsilon is. So we need to make sure that part of our proof will end up to this form. So in order for us to look into the appropriate expressions or processes part of our proof, let's try to come up with the expression that is related to our definition. So our x sub n, the sequence is 3n plus 1 all over 7n minus 4 minus the limit of 3/7 must be less than epsilon. Let's try to show the target expression that we need to have later so that it would be easier for us to start with our proof. So I'll simply combine this. You will have, pardon for that, of course it would need us a lot of spaces. So that's actually 7 times 3n plus 1 minus 3 times 7n minus 4. Okay, please review the necessary processes involved in this part. All over 7 times 7n minus 4. So that would mean you will have here 21n plus 7 minus 21, sorry, that's 21, 21n plus 12. Yeah, that's plus 12 all over 7 times 7n minus 4. Let's not multiply the denominator. This must be, let me change the color of my pen, must be less than epsilon. Okay? So as we move further, you will have here that is 0. So you have positive 19 over 7 times 7n minus 4 less than epsilon. Let's not multiply the denominator because we need to come up with an expression also later with n. So we will have 19 over 7 times 7n minus 4 less than epsilon. If we reach this type of expression in part of our proof, or we need to be guided to make sure that we reach this so that we could arrive to our intended output, that it should satisfy this absolute value notation less than epsilon. Still, I'm talking about an expression equal to n because we will have that later. So we need to solve n for this inequality. You could have here 19 over epsilon is less than, or let's stay 7 here. You'll have 7n minus 4 because we are solving for n. Then you will have here 19 over 7 epsilon plus 4 is less than 7n. So for our n, it's less than 19 over, when you divide 7 both sides, that's 49, 7 times 7, epsilon plus 4/7. This is very important as we also come up with an assumption later on the value of k. Okay? Take note of that. 19 over 49 epsilon plus 4/7 is less than n. And that's actually taken from this, which again will come out to this later. Okay? So please bear with me as we start now with our proof. That's just part of the preliminary computation. Because this will be our proof, we will introduce an epsilon greater than 0. And we will let, okay, we will let the value of k, as this is needed on a part of our proof, be equal to this expression less than n. Sorry, you cannot see my scribble here because it's white. So this one here, okay, it should be like that. So I'm gonna return to white. So this is equal to 19 over 7, sorry, that's 49. 49 epsilon plus 4/7 be an element of real numbers. Okay. Take note that in the definition, it should be a natural number k, but our k here may not be a natural number depending on the value of our epsilon. Nevertheless, you will have here, then n, let's just simply use greater than instead of greater than or equal per definition, because then again, k is not a natural number here, k, okay, which is equal to 19 over 49 epsilon plus 4 sevenths. Okay, once you will have this, this implies something which implies simply n removing k in the picture greater than 19 over 49 epsilon plus 4 sevenths. Okay, so as you can see, this arrived here. This is actually similar to this one here. So this one, again, let me change my pen here. So this expression here, okay? So we are now going to the target expression guided by our previous expression earlier. Then let's simplify this to make sure that we'll arrive to our epsilon. Okay, so what we could do is multiply both sides by 7. So you have 7n still greater than 19 over 7 epsilon plus 4. Okay, as we multiply both sides by 7. Now let's subtract both sides by 4. So you will have here 7n minus 4 is still greater than 19 over 7 epsilon. Let me change the color to black. Okay, and then as we multiply both sides by 7 epsilon over 7n minus 4, you will have here 7 epsilon is equal to, sorry, not equal, greater than 19 over 7n minus 4, which will give us again the value of an epsilon greater than 19 over 7 times 7n minus 4. Or you could interchange this to 19 over 7 times 7n minus 4 less than epsilon. So we have arrived to this one here. Hence, for n greater than k, we have, okay, our original expression earlier, this one here, this one here, okay. You will have absolute value of 3n plus 1 over 7n minus 4 minus 3 sevenths, which is equal to 19 over 7 times 7n minus 4 is less than epsilon. Cutting here, you will have the absolute value of 3n minus 1, sorry, plus 1 over 7n minus 4 minus 3 sevenths is less than epsilon. And this is the last portion of our definition. It should satisfy that. Since it satisfies that, we can now say, therefore, the limit of the sequence of 3n plus 1 over 7n minus 4 as n approaches to infinity is equal to 3 sevenths, and it converges to 3 sevenths. This is now the end of the proof, as we were able to establish this expression taken from the previous scribbles here. So again, to prove something like this, we start from this here, coming up with the correct expressions that will be used for n. We'll have that for our k, which is, and then n greater than that. As we manipulate that to solve for our epsilon, we can now go to this, looking into this expression for the absolute value of the difference of our sequence, and its limit is less than epsilon. Then you could have this conclusion. Thank you very much for watching.